This outstanding engine offers the greatest degree of efficiency, durability, and refinement. The engine can be constructed in either aluminum alloy or cast iron construction depending on the original requirements. The specific fuel consumption rate of the engine when directly coupled to the dynamometer is the remarkably low value of 0.360 lb per b HP/hour. It is commonly used in motor yachts across the globe, and of course many automotive vehicles and locomotives. L. Gardner and Sons Ltd was a British builder of diesel engines for stationary, marine, road, and rail applications. The company was founded in Hulme, Manchester, England in 1868. It started building engines around 1895. The firm ceased engine production in the mid-1990s. LW engine was a modular design, with separate cast iron cylinder blocks and cylinder heads comprising either 2 or 3 cylinders. A 5-cylinder engine would thus use a 2 and a 3, whereas a 6-cylinder engine could have either 3 2s or 2 3s. Boat engines had a cast iron crankcase, whereas, in the interest of lightness, road vehicles would have an aluminum alloy crankcase. Any boat engine with an alloy crankcase would be a marinized road engine. The Gardner engine's reliability and economy. Tests showed that even a 2-ton Bentley could achieve 30 miles per gallon of fuel while having a top speed of 80 mph. Coupled to its remarkable refinement and smooth running abilities, made it the only suitable compression ignition engine at the time. During World War II, 1939-1945, Gardner's war work consisted mainly of building diesel engines of their own design. Their 4LK bus engines were also used as the main power plant in the Royal Navy's X-class and XE-class midget submarines. The MAN D2866 diesel engine series is available in 2 versions, D2866 2V and D2866 4V. The 4-stroke engines of this series have 6 cylinders. The engines use a direct injection system, which has many advantages. MAN D2866 engines are equipped with an exhaust turbocharger with an intermediate cooling system. Regular water is used as a coolant in the engines of this model. MAN D2866 2V are motors designed for industrial use and installed in electricity generators. By the type of load, the generators should be classified as LTP units, limited time power. That is, they work in the so-called standby mode, which allows them to be used up to 500 hours per year at variable power and 300 hours in a row, with maintenance breaks, without overloads. The MAN D2866 4V is a motor variant for use in generating sets of the PRP, prime power, classification type. This type assumes continuous use of the generator to generate energy for an unlimited number of hours per year. These generators are able to withstand overload unlike the LTP type. True, only 10% of the permissible power and no more than 1 time in 12 hours with a duration of no longer than 1 hour. The volume of the MAN D2866 valve is 11.9 liters. The weight of the engines is 1180 kg, and the power generated by them, depending on the modification, is 280 or 322 kbv. The maximum torque of the engines of this series is 1782 newtons or 1708 Nm, depending on the configuration. The working area of the MAN D2866 2V engines is also 11.9 liters. Depending on the modification, the rotation speed can be 1500 RPM 50 Hz or 1800 RPM 60 Hz. Accordingly, the generated power reaches 360-400 kW. D2866 LF34, 6-cylinder inline engine with water cooling, produced since 1998. Engine power is 310 HP, 228 kW, with an engine volume of 11,967 cc. The Wright R975 Whirlwind was a series of 9-cylinder air-cooled radial aircraft engines built by the Wright Aeronautical Division of Curtiss-Wright. These engines had a displacement of about 975 cu in, 15.98 L, and power ratings of 300-450 HP, 220-340 kW. They were the largest members of the Wright Whirlwind engine family to be produced commercially, and they were also the most numerous. During World War II, Continental Motors built the R975 under license as a power plant for Allied tanks and other armored vehicles. Tens of thousands of engines were built for this purpose, dwarfing the R975's usage in aircraft, where it was overshadowed by the similar Pratt & Whitney R985. After the war, Continental continued to produce its own versions of the R975 into the 1950s. Some of these produced as much as 550 HP, 410 kVlar. The R-975 powered the American World War II M18 Hellcat tank destroyer, which was claimed to have been the fastest tracked armored vehicle until the introduction of the turbine-powered M1 Abrams in the 1980s. As the most powerful whirlwind to be produced, commercially it was also the most successful. It powered a wide variety of civil utility aircraft, such as the Beechcraft Staggerwing, and various airliners, such as the Ford 4ATE Trimotor and the Lockheed 10B Electra. In addition, it powered U.S. military training aircraft, including the North American BT-9 and Vultee BT-15 Valiant for the Army, and the Curtiss-Wright SNC Falcon for the Navy. The Curtiss F-9C Sparrowhawk Parasite fighter operated from U.S. Navy airships was also powered by the R-975. The Wright R-3350 Duplex Cyclone is an American twin-row, supercharged, air-cooled, radial aircraft engine with 18 cylinders displacing nearly 350 cubic inches, 54.9 L. Power ranged from 2200 to over 3700 HP, 1640 to 2760 kV, depending on the model. Developed before World War II, the R-3350's design required a long time to mature before finally being used to power the Boeing B-29 Superfortress. After the war, the engine had matured sufficiently to become a major civilian airliner design, notably in its turbo-compound forms, and was used in the Lockheed L-1049 Super Constellation airliners into the 1950s. Its main rival was the 4360 AN-3, 71.4 L, 4300 HP, 3200 kW. Pratt & Amp Whitney R-4360 Wasp Major first run some 7 years after the Duplex Cyclone's beginnings. The engine is commonly used on Hawker Sea Fury and Grumman F8F Bearcat Unlimited class racers at the Reno Air Races. To save weight, the engine crankcase was made of a magnesium alloy, however. Magnesium is flammable metal and can produce a fire hot enough to burn through the aircraft structure. This happened on the second Boeing B-29 prototype after an engine caught fire and burned the wing spar, causing a catastrophic wing failure. All 11 crew members were killed, including Boeing's chief test pilot, Eddie Allen. Other problems were encountered during early use as the engine tended to overheat and was prone to swallowing valves. During operational use in the Pacific, the hot climate and heavy loads caused serious engine overheating, and magneto run-up checks were delayed and performed during the takeoff run to prevent engine overheating.